Welcome to a new video which is about limits in vertical asymptotes. In this video I will explain the definition and give a general tip to solve such questions. After introducing the subject, I will solve instructive examples. If this is your first time here and if you want to support this channel, don't forget to subscribe, click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. Here guys, we have a definition. It says line x is equal to a is a vertical asymptote of the graph of a function y is equal to f of x if either limit of f of x when x approaches a from the right side goes to positive or negative infinity, or when x approaches to a from the left side, and again the limit of the function is negative infinity or positive infinity. So basically what we are trying to find out is which x values makes the function to go to infinity, positive infinity or negative infinity. So we will try to find out those values, and those values are called vertical asymptotes. And we have a tip for that. Generally those functions are fractions, and in such fractions always we look at the value which makes the denominator 0. We will find out such values in fractions. You can just benefit from that information. And we have an example, and it says find the vertical and horizontal asymptote of the function f of x which is given us here. As a reminder, this information gives us how to find the horizontal asymptote. By the way, I just give it there for you. So our function is f of x, and which x value makes the denominator 0? Of course, as we see here, negative 7 is going to make the denominator 0. It's very obvious. So we can say that vertical asymptote is equal to negative 7, of course. Why? Because limit when x goes to negative 7 from the left side, x plus 8 divided by x plus 7 is. Limit of f of x when x goes to negative 7 from the left side, denominator is going to be almost 0, but it's going to be like approaching 0 from the left side. So in this case, the limit is going to be negative infinity, guys. If we say when x goes to negative 7 from the right side, that idea is similar to approaching 0 from the right side. And in this case, the limit is going to be positive infinity. In other words, vertical asymptote is negative 7 in this function. And how we can find the horizontal asymptote? We will take a look at the case where x goes to positive infinity or negative infinity. We write limit when x goes to, let's say first a positive infinity, x plus 8 divided by x plus 7, and that is equal to, guys. Actually, in such questions, guys, if you look at the highest powers, which is x in the numerator and x in the denominator, and we will just take a look at their ratios, okay? Because there is 1 here and there is 1 here, so we're going to have 1 divided by 1, which is 1, guys. So we can say that when x goes to positive infinity, the result is 1. Similarly, if you put negative infinity, still we're going to get the same thing. Negative divided by negative is going to be still positive. So still we're going to have 1. In this case, we can say that horizontal asymptote of this function is 1, guys. This is the faster way that you can solve such questions. But the regular way is if you take the numerator in x parentheses, then we're going to have 1 plus 8 divided by x divided by, take the, here I'm talking about this function, take the denominator in x parentheses as well. So it's going to be 1 plus 7 divided by x. And when x goes to infinity, those cancel. This goes to 0, this goes to 0. 1 divided by 1, still we're going to get 1. So this is the general way that we solve such questions, but the way that I solved it here is a faster way. And let's take a look at our next question. We have a new question, and it says, guys, find the vertical and horizontal asymptote of the function f of x where the function is negative 6 divided by x squared minus 9. I put here the graph of the function to give you a clear picture actually. If you look at the graph, this point is negative 3 and that point is positive 3, guys. And those points are what? Those points are the values which make the denominator 0. So this f of x can be written as negative 6 divided by, if you factor this, okay, we can write it as x minus 3 times x plus 3. We can benefit from a famous algebraic equation, which is a squared minus b squared can be written as a minus b times a plus b. So x squared is the square of x and 9 is the square of 3. If you factor this, then we can write it in this form. So as you can see here, in the first term, in the denominator, positive 3 value makes the denominator 0. By using the second term here, we can see that negative 3 makes the denominator 0. So positive 3 and negative 3 are vertical asymptotes. We can say this by using the tip. So we can say that limit when x goes to 3, let me just put it here, basically f of x, okay? when x goes to 3 from the right side, and then we're gonna have negative infinity, guys. Actually, we can see it here. Okay, this is the point 3, and if we approach this 3 from the right side, okay, right side over the function, and as you can see, the function goes to negative infinity. If you approach 3 from the left side over the function goes to positive infinity, guys. Why? Because of that negative sign. Actually, this is why it is going to positive and negative infinity. Similarly, limit when x goes to 3 from the left, f of x. Okay, left means a number which is, let's say, 2.99. So if you put 2.99 instead of x here, then in the denominator we're going to have a negative value. And because of that negative value as well, so negative is going to be positive. That is why when x goes to 3 from the left, we're going to have positive infinity, guys. And as you can see, actually you can see it from the graph as well. When you approach 3 from the left, the function is going to positive infinity, guys. So negative 3 is the similar idea, because as we saw here, negative 3 is a root of the denominator. That is why when x goes to negative 3 as well, the function goes to positive infinity and negative infinity. So that means we have two vertical asymptotes, which are negative 3 and positive 3. These are the vertical asymptotes. How about the horizontal asymptote? Horizontal asymptote means limit when x goes to infinity, guys. Let's say first positive infinity. F of x, negative 6 divided by x squared minus 9. And as you can see, our variable x squared is in the denominator. That means the function is going to behave like negative 6 divided by infinity, guys. So that is going to be, of course, 0. If x goes to negative infinity or positive infinity, it doesn't matter, okay? Actually, we can see it also by just looking at our graph here. And as you can see, the function is approaching 0 when x goes to positive infinity. The function is approaching again 0 when x approaches to negative infinity. As a result, we can say that horizontal asymptote is 0, guys. We have horizontal asymptote as 0. And let's continue with the next question. And this is our last question, guys, in this video. And again, we are asked to find the value of vertical and horizontal asymptotes. As I said before, in order to find vertical asymptotes, we will take a look at the values which make the denominator 0. X squared minus 4 can be written as x minus 2 times x plus 2, guys. Why? Because x squared is the square of x and 4 is the square of 2, guys. So that means our f of x is limit when x goes to 2, f of x. So if you approach 2, okay, because 2 makes this part 0, denominator 0. So if you approach 2 from the left or from the right, we're going to have a vertical asymptote. When x approach 2 from the right, actually, think a value which is a little bit greater than 2, let's say 2.01. In this case, this part is going to be positive, okay? So our limit is going to go to positive infinity. But limit when x goes to 2 from the left, f of x is equal to, guys, in this case, think x value as 1.99. So if you put 1.99 here, okay, here 1.99, we're going to have negative from here, right? Because 1.99 minus 2 is going to be a negative value. So in this case, we're going to have a negative infinity in this case. So we can say that we have two vertical asymptotes, positive 2 and negative 2. But how about horizontal asymptote? Horizontal asymptote is the value when x goes to infinity, guys. And if you look at the function here, okay, let me write it here. Limit when x goes to, let's say, positive infinity. 6x squared minus 4x plus 2 divided by x squared minus 4. The highest powers of the numerator is x squared and its coefficient is 6. And the highest power of the denominator is again x squared 2 and its coefficient is 1. Because those are equal to each other, okay, x squared, and I will just take a look at the ratio of those coefficients. In other words, this is equal to, guys, 6 divided by 1, which is 6. This is the short way. But the general way is, if you take the whole numerator in x squared parentheses and whole denominator in the x squared parentheses, like x squared times 6 minus something, and in the denominator we're going to have again x squared parentheses. We have just 1 here minus 4 divided by x squared, and this is a division. We can just cross out x squared values. All the terms goes to 0 here. This term goes to 0 here as well. And as you can see, we have 6 divided by 1 left over. And once you do it, still we're going to get 6, and this is the common way that you can find out the horizontal asymptote. Okay guys, this question was our last question in this video. If you have any questions regarding the subject, you can put them in the comment section below. Thank you for watching and hopefully see you in the next video.